So dear world, welcome back to the house robbery problem 2. So first let's understand this house robbery problem. Okay, so it's telling you are a professional robber planning to rob house along a street. Each house has certain amount of money stashed. So it's telling that each house is having certain amount of money. Wall house at this place are arranged in a circle. So the most important point to remember here that wall house is arranged in a circle. All houses are arranged in a circle. So this is most important point from house robbery 1. Second, that means the first house is the neighbor of last one. That means the first, if mean this is the last and this is circle, so first and last are neighbors. This is also important point. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken on the same night. That means it has a security system same like house robbery problem 1, that if we break the two houses at once, it will automatically call the police. And the main motto is that we don't have to call the police. Given an integer array nums representing the amount of money each house. So this nums represents the number of money in each house. Got it? The first one. So return the maximum amount of money you can rob tonight. So this is telling that we have to find the maximum amount of money. So try to understand what is this max. When we get problem like max, minimum, so we have to understand this is the problem of optimization. That is the problem of optimization. So let's understand it. The important point is stating that the most important point here is that arranged in a circle, arranged in a circle. Second important point is it has adjacent security system, and the third, that is maximum amount of money. So we have to find the maximum amount. Whenever we got maximum amount, that means we have to understand it is the problem of optimization. Optimization. And when we get problem of optimization, that means we have to apply dynamic programming. We have to apply the concept of DP. Okay, so let's try to understand how we can solve this. Let's try to understand the approach. So before we try to understand the approach, one important thing, we have to observe the constraint, that what is the constraint given. So let's observe the constraint. Okay, we are in the house robbery problem 2. So the constraint here is that 1 less than equals to nums dot length less than equals to 100. So that is the constraint, that 1 less than equals to nums dot length. So the constraint given here is, this is the constraint, 1 less than equals to nums dot length less than equals to 100. That means what? This is the constraint given there. So that means nums dot length. So this is the nums and it represents the house number. It represents house number. That means the house number will be between 1 to 100. That means the house number will be always between 1 to 100. So it represents that the house number will always be between 1 to 100. 1 to 100. So we got this one. So our base case. So whenever we solve the programming, we have to find the base case, or we call it a terminating case. So let's try to understand how we can solve. So first we'll be figuring out the base case. Let's write here base case 1. Base case 1. Okay. So what might be the case? The first case might be that there is only one house. There is only one house. So let's say that is the house, and the amount of money in house is 2. In base case, the amount of money is 2. So what we'll be doing? If there is only one house, so we'll just rubber that house. So if we get that type of case that there is only one house, then we'll be doing like, we'll be returning just that number. So we'll be writing the program line like this: if n equals to 1, that means the array length or house number equals to 1, then we'll simply return nums of 0, because the first element is always stored in nums of 0. So this is the base case 1. Second case, what if there is two elements? That was only one element. Now base case 2. Now we'll be discussing the base case 2. Base case 2. Now let's try to understand there is two elements like 2, 3, 2. So we are taking the first two and 3. So here is two elements. So what it is told in the question, this is told in the question that among two houses, we can rob from only one, otherwise it will call the police. So we have to call from only one house. So we will be calling the maximum because we have to maximize our profit. So for then we can write that if the house number is 2, that is if n equals to 2, So we'll be writing return math.max because we want the maximum one. So in Java we use math.max nums of 0. It will store the first profit 2 and nums of 1. It will store the second profit nums of 1. So this is, it will store 3 and we will get the maximum profit. So these two are the base case. This is for base case. But what will happen in the program? What is the constraint? The constraint was, look, 0 less than nums of are less than 1000. That means it is telling that we can have a large value, large number of houses of 1000. So these are the base cases, that is for one value and two value, and it will go up to 1000. So we have to think up to the last case. We have to think up to the last case. So let's try the third case, third and more case. What if there are houses greater than 2? For houses greater than 2, general case, we can call it that this is a general case. For houses greater than 2, for houses greater than 2, for houses greater than 2, what will be there? So if we have houses greater than 2, so we can think the problem like this, because here one important thing is told that arranged in a circle. This is very important things. So let's consider we have 3, we have 3, we have something like 2 3 2. Now we are considering this example. So how we can find it? This 2 3 2, 2 will be like this, 3 will be like this, and this 2 will be like this. So these are the houses here, and as these are told, these are in circular manner. So we have to find the maximum one. Now just think in general how we can find the maximum one. Look, if we just find it, the first one, this is the starting 2, that is the starting 2, so just that is our starting point. So if we just consider it 2, so if I just choose this 2, so I cannot choose 3 automatically. Automatically I cannot choose 3. Now if I try to choose this 2, I also cannot choose that one also. Why? Because they are in circular manner. That means important point to notice is that if they are automatically forming a circle, there is a circle, and there is also a circle. There is also a circle. So notice the case that there is another different type of things that we cannot include that. So we can think in another different manner. We can solve this problem like this. We have to think like this. There is 2, the house number 2, the house number 2, the house number 3, and the house number 2. So if we 2 3 2, 3 is actually hidden. Okay, so you can see the 3. So now try to observe that if we consider like this, that now we can consider in shift test. In first shift we can consider that we will not include the last. If we start from here, we will not include the last. Look, now we are not including the last, so we can easily find the maximum from here. Just we will be utilizing the formula math.max. We will be utilizing formula math.max. Number 1 and number 2 case, what we can do? Okay, we will again write the same things. The example was 2 3 2. Nums, nums, that was 2 3 2. And okay, so first our houses in our first strategy case 1, that was 2 3 2. So how we could actually took from here? We could take this one. If we would consider this section 2 3, so we could easily get maximum from here, that would be 3. That was case 1. That is case 1. In second case, in second case, case 2. So case 2 we can observe the same like this, 2 3 2, 2 2 3 2. So in second case we can take this one. First time we have included the beginning. Look, in here we have included the beginning. So in second case we can exclude the beginning and we can include the end. Here end is not included, end is not included, end is not included, end is not included. In this section we haven't included the end. And now look, this is the beginning. Here we haven't included the beginning. So one time what I did, we didn't include the ending one, and one time we didn't include the starting one. So that is what we'll be applying here. So here we haven't included the starting one, included the starting or first one, the starting or first one. So okay, we understood this thing. So this is generalization. If there is three elements, if there is three elements in nums or four elements on nums, 5, 6, 7, 8, it will work for all the cases. But how we can think? Now let's take another more greater example. We'll be taking another more greater example. Let's say we have an array of like this: 1, 2, 3, 4, 5, 6, 7, 8. So how we can understand from here? If 1 is our starting point, let's consider 1 is our starting point. 1 is our starting point. So there is two way how we can solve it. First, we're starting from 1. We're starting from n and we'll consider our problem up to that section. Here we're not including the last one. Not including. This is case 1. That is called case 1. And the second case how we can do? We can start from the ending section. Look, we can start. I mean, we will be actually starting from this section in our code. So we'll be starting from the second section. And now in the second part, we'll move up to the last one. Move up to the last one. So this is the second case. So in first case, what we have done? First case we have included the beginning but not the end. In second case, we have included the ending but not the front one. So after that, the first one will give us a result and the second one will also give us a result. It will provide us some value. So let's say it will provide some value and it will also provide some value. And if we just take the maximum of those two methods, that is, if we just do the math.maximum, math.max, math.maximum of method 1 comma method 2, so it will return us the global maximum. So we'll get the global maximum from here and that will be the answer. So we have to find the global maximum. So till now we understood. Now how we can find the global maximum? That is very easily. That is same like rubber problem 1. So what it did in rubber problem 1, if you try to understand the rubber problem 1, so that is like this. So 1, 2, 3. Let's say 10 elements and we try to find the index of this element. So if we call it n, so either there was the rubber 1 problem and 2 problem, both problems are similar, that we cannot take adjacent. So in anywhere we could not take the adjacent. So we would not be taking adjacent. So we could either take n and n minus 1. We could include this n minus 1. I mean this is n minus 2. So we could include this n minus 2. So this would be the cost of numbers. So that what would be the cost of the nth index? That would be nums of n, nums of n, and that would be the cost of dp of n minus 2. You might be thinking, why dp of n minus 2? Because dp is the sum of all those. If there are more previous elements, dp array will contain the sum, the cost, the summation cost of all. So that's your dp of 1. And now we have done this in there could be another second case, is that there is 1, 2, 3. So we could also do that instead of taking this 3, so there was n, this is the value of n, so we would just include this one, we would just include this n minus 1, the cost up to this dp of n minus 1, and it could also provide us the best result. If suppose it was 8, so it would be our choice. So that was the two case. So how could we generalize? We would also take maximum from case 1, that is case 1, and that is case 2. So we would take maximum like this. So we would generalize like this: math.max, math.max equals to dp of n minus 1, dp of n minus 1, or dp of n minus 2 plus nums of n. and we would assign that one to dp of n. dp of n. So if you would like to generalize like this in terms of program, because the value of n will keep changing with respect to I, so we could generalize like this. That's dp of I equals to math.maximum. Look, we're utilizing here Java. dp of I minus 1 comma dp of I, that is I minus 2, plus nums of I, that is at that index, and that would provide us a value. So let's see in the program how we can utilize this one. Okay, so we are already in the program and I have already done. So we'll again construct from here for better understanding purpose. So first, that was the entire additional code. We'll be just removing this. So this is the basic where we have created first solution object, and this is array declaration, and then we have called this raw function, that is we have passed the entire value in raw. So first we'll be starting the raw function by calculating the length of the array, integer n, that is equals to nums dot length. This is array, so dot length function is utilized, and this is important because it will tell us the number of houses. Now we'll be handling the edge cases, base case or the terminating case, I call them terminating for better understanding purpose. Okay, so first we'll be checking if there is only one house. If n equals to 1, then we'll be simply returning the cost of first house, that is nums of 0. So we return nums of 0. Second, we'll be checking if there is two house, that is if n equals to 2, then we'll be simply returning the maximum amount the 2. So return math.max nums of 0 comma nums of 1. So these are the two base cases where we handled. Now what suppose we have more than 2? For more than 2, houses. So more than 2 houses, I've already saw you in the program that we have two approaches. First we have to start from the starting, but we don't have to include the last one, and the second will start from the second index and we will include the last one. So simply we'll do that for here. So first we'll be writing for the case 0, case 1, case 1, case 1, where we'll be writing from 0 to the value n minus 2. Okay, so integer raw first, let's call it raw first range. So we'll be constructing a raw linear function, and then we'll be passing the entire array, our starting index 0 and the index index n minus 2, where we're going to stop. Integer raw second range. So now again rob linear, the function already created. Now we'll be passing the array num 0, and now we'll be starting from 1. 1 will be the next index, and we will including the last one also, n minus 1. n minus 1 because n minus 1 is the last index. And now among them we'll be returning the optimal maximum from the two sub methods. So okay, so we'll be returning the return math dot max raw first range comma raw second range. Okay, so we constructed the function, and now we need to construct the raw linear function. So it's very easy. It was just like the house robbery problem 1. So first we'll be checking the edge case, and here the edge case will be the problem 3 if the starting and ending is same. So if the start and end is same, somehow it might be the case. So we'll be check and we'll be returning the index of that element. So if start equals to end, then we'll be return nums of start. Okay, so we handle the first case. Now we'll be creating a dynamic array to store the maximum amount we can drop. So we'll be creating an array. integer dp new integer. So we have created the dynamic programming array. We'll be moving towards the next step right now. Now we'll be initializing the first house range, that is dp of 0. dp of 0 will be equals to the start range, because from where we start that becomes the first house in the range. So that is the start range. First house money amount. Now we'll be initializing the dp of 1. That means if there is two houses dp of 1, then we'll be choosing the maximum one. So we'll be utilizing the java math.max function. Nums of start comma nums of start plus 1. Then we'll be applying for more than two elements when house is more than 2. So in that case we'll be utilizing the function for integer I equals to 2, I less than dp dot length plus I plus plus. And now the generalized formula dp of I that I made you understand, math.max nums of start, because each time we start from I and I will be increasing with that respect, plus dp of I minus 2 comma dp of I minus 1. So that is the dynamic programming range, and now we'll be returning the last index, that is dp of dp dot it length minus 1. So okay, now we are running the program and checking if there is an error or not. Okay, so we can run the program. Okay, it got accepted. That means everything is correct, and it got submitted and paid 100%. So we will be meeting in the next video in the house robbery problem 3.